Hi there, and welcome to today's webinar, Robotic Demolition Equipment Offers New Approach for Worker Safety in the Bottom Line, hosted by Brock Inc. and Modern Casting Magazine. I'm Shannon Wetzel, Managing Editor, and I'll be your moderator for today's session. Today's speaker is Peter Bigwood, Vice President of Sales and Marketing for Brock's North American subsidiary. Peter has more than 25 years of industry and leadership experience. He is a member of AFS, the National Demolition Association and Concrete Sawing, the Drilling Association, and Steel Manufacturers Association. While today is about hearing from an expert in the field, we also want to hear from all of you in the form of questions. To ask a question, look to the right side of your screen and locate the GoToWebinar control panel. On it, you'll see a section called Questions. Click on the plus sign and then just type in your question in the available space. I encourage you to submit questions at any time during the webinar, and we'll be responding to as many of them as we can during the Q&A session after the presentation. What we can't answer on air, we'll do our best to answer as quickly as possible over the next few days. Also, please note that today's webinar is being recorded, and we will send a link out to you by the beginning of next week so that you can view or share today's event as an on-demand viewing. And with that, Peter, we'll hand it over to you.
Well, thank you very much, Shannon, and thank you all for joining us today. I'm very pleased to have this opportunity to tell you everything you ever wanted to know about demolition equipment and foundries. Brock is a Swedish company. We invented the demolition robot concept 40 years ago, where the first application was to clean out a lead smelting plant. So it's really not a new approach, but over the last few years, we've noticed a rapid increase in the demand for this type of equipment from foundries and other metal processors. And we've identified three macro trends that we see as supporting this phenomenon. First, an aging workforce of folks who are using handheld tools but are becoming less and less able to do so. Number two, younger workers unwilling to take on the physically challenging and strenuous tasks involved in demolishing refractory and other materials. And then third, the rising cost of workman's comp and lost time accidents and injuries on the job. So what we find is that we've been active in North America since 1983 as a sales company for these machines. The first production demolition robots were called Minimaxes, and later they were called B250, which is still the most popular model in the history of these machines. That one weighs about 3,500 pounds, and now there are 6 main models ranging from just 1,000 pounds, which we'll see later, and all the way up to over 24,000 pounds, or about 12 tons. And all of the units are available with electric motors driven by 480-volt 3-phase power, which means no fumes, but it also means they have incredible power-to-weight ratios. And then there are 3 models also available with diesel engines. And demolition robots is actually a bit of a misnomer. We prefer to call them remote-controlled demolition machines, but it doesn't exactly trip off the tongue, so most people just call them demo robots. And wireless radio controls means that they can be operated from as much as 300 feet away, although most people, as you'll see, stand about 10 to 20 feet away from the work. So the key benefits, the 3 key benefits of the robotic equipment, they're compact, they're efficient, and they're safe. The 3 smallest units can all fit through a standard doorway. The largest of those, a B160, can reach 14 feet horizontally and vertically. And the 3-part arm found on all of these machines, unlike the traditional two-part arms on excavators and backhoes offers better geometry and that allows the operator to reach into tricky areas and exert force at difficult angles. And we like to say that a Brock machine earns its living on walls and ceilings. They're efficient, especially after lunch. And the photo here shows a typical operator holding with the remote control around his waist. And we like to say that the best operators of these machines are young people who have played video games. The joysticks are similar to Caterpillar controls, so the learning curve is fairly steep. It's fairly easy. And of course, safety, which is a huge part of the entire concept. Operators can position themselves wherever it is safest and still maintain a good view of the work. So let's talk a little bit about safety and what can happen out there in the real world. A large percentage of the foundries who bring us in are looking for alternatives to having their labor force use handheld pneumatic tools in these tough environments. And as we know, there are any number of hazards present in foundry work, and where we are particularly involved, we see the repetitive motion injuries, injuries where workers are in awkward postures, trying to exert high levels of force to remove material, and of course the vibration of the tools themselves. And we see a lot of musculoskeletal disorders, or MSDs, which is a very common disorder in the foundry industry, accounting for 32% of all injury and illness cases in 2014, for example. And the leading cause of injury and illness in 2014 was sprains, strains, and muscle tears, with over 420,000 days away from work cases. Injuries we also see, of course, in lower back and often in upper limbs. And in 2014, workers who sustained sprains, strains, and tears required an average of 10 days away from work. Folks who had fractures were away for 32 days on average, which is more than triple the time out of work for the other injuries. So again, a serious phenomenon that has contributed mightily to the interest in these kinds of machines. Another issue, of course, is the heat that everyone is well familiar with in the foundry industry, and the fact that the equipment can be remote control or is remote controlled is obviously a critical factor here. The machines are designed to withstand all the elements thrown at them, excessive heat, high levels of dust, and harsh chemicals. And I should add here probably that the equipment is used extensively in nuclear applications, as well as tunneling, mining, cement process, as well as construction and demolition. And this photo shows our 12-ton unit, the B800, in a steel mill, and the ladle visible there in the foreground is a 160-ton size, just for comparison purposes. And the operator of this machine is actually sitting up in the control room. I'll give you an idea of the usefulness of the remote control application. So we found, as I've mentioned, that foundries are an excellent environment, well suited to the advantages of bringing in demolition robots. The equipment is designed to withstand the high heat. It is less likely to break down and keeps operators out of dangerous situations. And what I'd like to do is to take a look at how the demo robots increase operator safety and productivity in foundry applications, and then as well as some specific examples of the successes that we've had in the foundry industry. So let's start with safety. And here is our smallest model. This is a B60. in operation, removing refractory material off of a cover. And this is a good opportunity here to take a look at how the machine works. You can see the stabilizer legs, which keep it on the stable platform as it's working. You can see the three-part arm and the hydraulic breaker on the end of the arm. We have any number of different attachments, including buckets and scabblers, even drills, but the hydraulic hammer is by far the most typical attachment used. And on this, the smallest machine, this is only a half a ton, that hammer is hitting about 5 times harder than any rivet buster that a laborer might use. And the secret is that as hard as it hits, the point can be very precisely controlled, and if need be, dialed back for very delicate work. And the operator, as we've mentioned, can stay well clear of any flying debris. So traditional methods, such as the aforementioned, chipping guns, rivet busters, pneumatic breakers, we've seen can cause costly injuries, and workers' compensation claims for back, shoulder, and wrist injuries cost businesses hundreds of thousands of dollars each year. And we remember going into steel mills many years ago where the workers would not be particularly welcoming, to put it kindly. And now what we find is when we do demonstrations, the workers will often come up to us and ask, are they going to buy this? Please tell us they're going to buy this. And again, I think that they're just reaching the point where they just don't want to do the hand work that they've been doing in these risky areas. And using data from several of our customers, we've seen over 50% reduction in workman's comp costs and over 75% reduction in back injury claims for the applications where robots are being used. Now here again, you can see how the operator positions himself for a good view of the work out of harm's way. And this, of course, is particularly important when high heat is a factor. So the demo robots reduced claims by not only by not putting laborers in dangerous situations. And here are some typical costs that we've come across for standard claims caused by repetitive and extended use of handheld pneumatic tools. Back injuries, of course, a big one, costing from between $100,000 and $150,000. A very common one that we hear about is the standard shoulder claim, which we see costing $50,000, and we've actually seen this as higher. One of our customers called it a $100,000 shoulder. And then wrist injuries, which are more common, typically we see about $15,000. So again, not inconsequential, and certainly one of the key factors in people taking a good hard look at this approach. So let's talk about some of the classic applications, and these are very common. I'm sure most of you will be well familiar with these. But probably the most common application for these machines in foundries are ladle cleaning. And again, the arm geometry, the fact that there are three parts to the arm system, means that these machines can have easy access and be very precise in where they hit inside the ladles, even the ladles that are quite small. And again, the hitting power of the hammer is multiple times higher than any handheld tool, and of course it doesn't get tired. So ladle cleaning, surprisingly, for most of these, are being done, especially the small and medium-sized ones, are still being done by hand. But as we know, it's a very time-intensive and hazardous task using the rivet busters, chipping guns, or jackhammers. And the number of our customers who have switched to demo robots in their foundries have seen incredible results, and we'll take a closer look at some of those examples in the next section of slides. A pretty conservative and typical gain in productivity is shown here. reducing the removal time of the material from 4 hours to 1 hour. And it's typical, but I would say, again, very conservative. And as you'll see shortly, we have examples where it's considerably more than this. But we talk about cold cleaning here because a number of our foundry customers prefer to wait for their ladles to cool down to prevent the chisel bit from mushrooming. For those facilities who want to attack the problem a little faster, as we've seen, a demolition robot can take the heat. And again, the model you're seeing here is our smallest one, the 60, with again the smallest machine, the smallest hammer on it. So if we go to our first case study, this was a foundry in the Midwest. And for all the case studies that we're presenting here, I should just point out that we have promised them all to preserve confidentiality. But if anyone would like to learn more or perhaps even visit any of these facilities, it may be possible. They have said they would entertain that, depending, of course, on competitive conditions and geography. But if you would like to pursue that, if you'd like to learn more, we can certainly help to facilitate that wherever possible. So this foundry is using a B100, our 1-ton model, which is one size up from the smallest unit we just saw. And they're using it to remove the refractory lining from iron pouring ladles. And before implementing the robot, this task would take 2 laborers 6 to 8 hours to complete it. And after introducing the B100, the task took a mere 2 hours and only required the 1 operator. So again, a 75% increase in productivity, depending on how you work the numbers. But we were pretty pleased with that. But more importantly, they were very pleased with that. Furnace cleanouts. This is a particularly a big one, but a very common application that we've come across inside the foundries. And this photo shows a pretty big furnace, of course, but that's our 3,500-pound model working there. That's a B160. And a lot of the furnaces we encounter in foundries, of course, are much smaller than this, but the challenges are very similar. This is an interesting one. This is a furnace application in an aluminum foundry in the south. Here they were using a combination of a mini excavator and laborers with handheld tools. And mainly they needed the handheld tools because the mini excavator couldn't reach into the entire furnace. And to make matters worse, its hammer wasn't powerful enough to handle the built-up material. So you can see how the Brock machine here which is a B160 model, is sitting on a pallet on a forklift entering the furnace. And the 3-part arm system allows it to reach everywhere inside the furnace, so only a minimal amount of handwork was necessary at the end. And again, it's cleaning out, breaking out a very hard material that's built up inside. Next case study, this one was in Wisconsin. This was an interesting one. When we were brought in, the plant was scaling off the material inside the furnace with workers who were also themselves inside the furnace. And so imagine a round structure lined with refractory throughout, with, of course, refractory overhead. And in this case, they were not there to remove the refractory, but just the built-up material, and they were using rivet busters. And here you see a pretty marked, difference in the 2 approaches. They had a small side hatch for access in the furnace, and they brought in a little B60, the half-a-ton model, to go inside the furnace. And with the operator staying safely outside, they did the work much more quickly and certainly more safely. And in fact, a contractor had been doing this work for the plant and determined that it was too dangerous. And so the plant brought in the Brock, and as you can see the results here, the task was completed on 2 of the Foundry's furnaces. And prior to using the robotic equipment, it required 10 laborers split into 2 crews working 10-hour shifts. And depending on the amount of buildup that had accumulated, the wall scaling took 3 to 5 days. But using the demo robot, the labor, of course, was greatly reduced, only requiring 1 operator and 1 spotter. And again, typically now the task takes 2 10-hour shifts to complete. And when the time comes to do a complete tear out of the refractory, the plan is to use the Brock machine again. And here, the safety ramifications are even greater. Previously, the workers who went in to do the refractory removal rigged up 2x4s to protect themselves from falling refractory. So not a situation that's very comfortable for anybody. Another little case study here was done in the same company but in a different plant. And cupolas are another fairly common application for demo robots. We've heard about and seen some pretty horrific methods for cleaning out cupolas, especially ones where molten material is still present. And one involved using a forklift rigged up with a steel pole pointing straight up from the forks, and the operator, fully suited up in heat protective gear, drove the forklift underneath the cupola and raised the pole up into the cupola. And I don't think OSHA would have been amused, and I certainly won't mention who the foundry was or where they were located, but this, again, we thought this was just not what should be happening. But in this case, the work is inside the cupola, and the old method in the refractory removal involved 3 to 4 guys holding heavy handheld tools, and it took 4 to 6 hours to complete. So using the robotic equipment greatly reduced the use of the handheld tools and increased the operations productivity by reducing the cleaning time to just 90 minutes with just the 1 operator. And follow-up finish work with just chipping hammers it took less than an hour and was much less labor intensive with, I think, 3 workers. And we often hear about another issue in foundries, and that is that the kind of workers who are capable of handling the tools in these sort of sometimes awkward operations are often the older, more experienced ones. And these are guys who we're told would be much more valuable in the facility doing other more meaningful work. So the demo robot actually frees them to do that, leaving a less experienced but trained worker to operate the machine. So another application, induction furnaces, is another good application in foundries for demo robots. Previously, mainly done with handheld pneumatic tools, with the accompanying physical strains on the labor. And now, using the demo robots, the labor is much reduced, and most importantly, injuries. And we had a very interesting one here. A large foundry in the south was doing exactly that. They were using workers who had to be fully suited up to climb into the furnaces with rivet busters to do the removal. And they actually had a large machine on the plant that they used to clean out their 100-ton ladles, but they didn't dare use it to clean out the induction furnaces because, of course, the very expensive piping systems inside, they didn't want to damage them. But using I think it's a B160, they now are able to do that with workers who do not have to be fully suited up, and they're very satisfied with the precision that they can do the work. Another application in foundries where, again, you have workers exposed to high heat is the runners and troughs. And the high heat is probably the biggest issue here, but another huge factor, of course, is productivity. You can do this much more quickly using the heavier hammers on these demo robots. And Typically, we're told, one of our customers told us that it's a six-factor difference, and that's using actually one of the smaller machines. And again, that goes straight to the bottom line. So another case study was we looked at was cleaning a cupola spout. This was a foundry again in Wisconsin, and the customer shared with us their experience. This was again using a B100, the 1-ton model, to remove the refractory material from the cupola spout, which, as you know, is more like a trough than anything else. This one was almost 30 feet long with a 1-foot thick refractory. And they tell us that they use the machine to carry out a thorough cleaning every 6 months. And prior to using the equipment, the refractory removal from the cupola spout required 8 laborers using 30-pound air guns and taking as much as 16 hours to complete. So with the demo robot, they reduced that to cutting the working hours nearly in half, but only using 1 operator and a spotter. And again, it takes 9 hours to complete. And not only does that save on labor and improve efficiency, but of course it reduces the employee fatigue and, as we mentioned, reduces the risk of injury. Another example of runner cleaning, also in the Midwest, and this was a weekly job cleaning out a channel inductor. And in this case, the sintered material was really, really hard and very difficult to break up. The foundry used a demo robot to remove the refractory from its runners every 8 weeks. And the task previously took as long as 4 hours to complete, requiring 4 laborers. The laborers used 40-pound rivet busters, in this case, to remove the refractory. But the material was, as I mentioned, the sintered material was very, very tough, and it caused the team to frequently break the bits on the rivet busters, sometimes going through as many as 8 bits during a clean out. So now, after adding the remote control machine, the labor, of course, is much reduced, and the task now only takes 1 operator, 1 spotter, and takes about 2 hours to complete. The equipment is stronger, and of course, we're not actually calling them rivet bits; they're actually chisels, but they're much thicker, and I think you use far fewer, and certainly not damaging them along the way. And it rounded up to 75% reduction in labor, and including, of course, the bit costs. Another interesting part of this particular case was that the foundry had been using a contractor to come in and do the work every 8 weeks at a pretty high cost, and now the work is done on an as-needed basis, all on straight time using in-house labor, which we saw as a real win-win. And so everyone pretty happy about that one. One other interesting application, really more for foundries who are doing large casting work, and is removing the baked-on sand from the large castings. And we've heard about some pretty hair-raising approaches to this problem, mostly involving those forklifts again, in this case being driven into the sand at high speed, and going through an awful lot of transmissions, we're told. But there is a better way. In many cases, of course, you're replacing, if they're not using the forklifts, they're using handheld tools. Also, as we'll see in a moment, sledgehammers. But we find that this is a very, very good application for demo robots. Excellent alternative to the manual labor, and the machines are very stable, very precise, and again, if you use a blunt chisel, you can remove an awful lot of the sand, and without damaging the underlying casting. So this final case study kind of brings it all together, and this again is using the demo robot to do removing the material, the sand, the baked-on sand from the casting. And this is a Pennsylvania-based foundry. They brought in the demo robots for the daily cleaning of the castings. And prior to adding the equipment, the task required 2 laborers holding 20-pound sledgehammers to break the graphite molds off of the parts. And typically the process took as long as 12 hours to complete, and often required using a torch to cut the excess material off of the parts. So you have the toxic gas issue now on top of everything else. And the physical tasks, this was costing the company, and when they brought us in, we were told that they had suffered 2 $75,000 injuries within a calendar year. And that was really what kind of brought us into the picture. So after the demo robot, they reduced the cleaning time to 45 minutes and eliminated injuries from the handheld equipment. Plus, of course, they eliminated the torch usage, or it certainly minimized it, and they were able to remove the caked-on material very efficiently. And interestingly, as I mentioned, the best approach here is a blunt chisel, not a pointed one, and the vibration of the hammer is very helpful in removing the excess sand very quickly. So, you've probably learned more about remote control demolition robots than you ever thought you would. I hope that the examples we've given here have sparked some ideas and given you some food for thought as you consider some of these issues in your own plants. And as I mentioned at the beginning, we are seeing a marked increase in interest from the foundries as the combination of factors, as I mentioned, the aging workforce, the difficulty in finding folks to do this kind of work using handheld tools, and soaring cost of injury and insurance has sort of conspired to make this aspect of foundry work such a challenge. And we hope that you've seen the very real benefits of using robotic equipment in the foundries, the compact size, the 3-part arm system for flexibility, the increased efficiency, and of course what we strongly believe in is operator safety. So we see that it's bringing greater safety, productivity, and accuracy, and we certainly hope that this has been of interest to you as you ponder these problems in your own plants. And here I am again, and certainly we hope that you'll come by and see us at Cast Expo. I thank you very much again for bearing with me as we go through all of these, and certainly if anyone has any questions, I'd be very happy to do my best to answer them. So thank you so much.
Thank you, Peter. And again, to everyone, if you have a question, please type it in the question box in your control panel. We do have a few that came in while you were presenting, Peter, so we'll go ahead and get started. First, what is the learning curve for when you first get a machine?
Oh, that's a good question. It does vary. As I mentioned, you know, it's funny. I mean, we sort of joke about it, but we do often find that the best operators are young people who have a history of playing video games. They kind of have spatial awareness. It helps if they are technically oriented or, you know, sort of technically competent. But that they tend to learn very quickly. And as I mentioned, the control system, the 2 joysticks on the control box, are patterned after Caterpillar machines, which in fact is pretty much the industry standard. So I think John Deere is the only one who might take a slightly different tack. But most excavator controls are similar to what you have on a demolition robot. There are some extra bells and whistles because you're doing some different things with it. But typically, you know, when people buy one of our machines, we give a 1-day training. That generally gets people off and running, and then with time, they get to be pretty competent. And again, I would say it's a fairly short learning curve depending on your background.
Great, thank you. And another one came in that said, do you have any machines that can rotate and hit like an overhead area?
The larger machines we have a rotating boom at one end. The B800 that we saw earlier in that steel mill application, that has a 360-degree rotating boom. On other machines, we offer what's called a side angling device, which allows you to rotate the hammer at an angle from the arm for really, really hard to reach, awkward sort of places to reach. We do find that in most cases, in most applications that I went through today, the standard configuration is more than adequate. And again, I can't. Obviously, the questioner was looking for rotation, but I can't stress enough how the fact that you've got 3 arms, and of course the machine itself rotates 300 slews over the tracks. So you really do have a lot of different approaches and a lot of geometry to work with as you're approaching the work. But yes, the direct answer is the largest machine we make, we do have a 360-degree rotating boom at the top.
Thank you. How about the maintenance cost of running a machine, either per month or per year, or your usage?
Yeah, that of course is as the British like to say, how long is a piece of string? Well, it depends very much on the string. You know, it depends, you know, on the working environment. You know, typically it is hard to put a number on it, but if you know, we have done that analysis over the years on different occasions for different applications, and you know, we can probably say with some degree of confidence, particularly in an industrial application where, you know, you're going around on flat surfaces, you're not climbing over rubble and things like that. You know, certainly less than $50 an hour, you know, in terms of, you know, accumulated, you know, parts costs, you know, filters and that sort of thing. And then, of course, if you have, you know, repairs to make, that changes things. But, you know, typically, if you do the daily and weekly maintenance, it is a very low cost machine to operate. And again, most of the machines that are in these applications today are the electric versions. Those are that kind of keeps things pretty simple. It's just an electric motor in there. And I would say that the single largest maintenance item for these robots is the cable maintenance. It's the cable. Our most successful customers have a good systems in place to manage the cable and make sure that you don't have bobcats running over it in the factory. And if you keep a good, clean electrical supply to the machine, which is generally pretty doable in a sort of a metal processing foundry type of environment, it is a pretty low maintenance type of machine.
Thanks, Peter. We have 1 or 2 more. First, is the complete job done with the robot, or is manual finishing required? Someone asked.
In some cases, as I mentioned, there is some small bits of handwork involved in doing the final cleanup. But in many cases, I'd have to say in most cases, you know, depending, is it complete refractory removal? Is it scaling? The nice thing about these machines, as I tried to convey, is that for all the power that they bring to bear, and I won't go into the secrets of why these machines are so powerful for their weight and size, but believe me, they are eye-poppingly powerful. But despite that, The nice thing about them is that they are also extremely precise. So you're not sort of bouncing around or waving the arms around in the air. You really are able to zero in on the work that you have to do with them in a very precise way. And you can also dial back the power or the frequency of the hammer, so that if you have a little area that you need to do, for example, taking off risers off of a large casting, people use it for that. And they can do that because you can be very precise. So I would say that in most cases you can do most of what you have to do with the machine and not worry about putting people in place, with the pneumatic tools in these high-risk areas.
Okay, and we'll do one last question. Someone asked, do you have any experience with riser removal and white iron?
Oh, well, as I just mentioned, yes. I didn't use that photograph in this presentation, but we have a wonderful photo showing a close-up of one of our Foundry customers using a Brock machine, again, a blunt chisel, so a chisel that does not have a point or a sort of a chisel face to it, but just a flat surface, using it to do exactly that, to just pop off the risers. And again, you need to be a pretty good operator to do that, but it's eminently doable, and it is being done. It is an application which these machines are absolutely suited for. So yes.
Great, and thank you, Peter, for conducting the webinar for us today, and thank you to everyone else for joining us.